Yo, what up? Is this thing on? Okay, cool. Mic is working. Always gotta double check that. How's everyone doing? Good, I hope. Welcome to the stream. Welcome back if you are showing up again, and welcome if you are new. Let's see. I've got a couple things open. I think last we were messing around with this before my system crashed. I was digging into ghidra, trying to figure out the functionality of this read sector memory function. So, uh, what we came to the conclusion of, at least so far, is that this 19-byte value is the header of the read sector memory message, and they're packing in a couple other values like the sector address, the length, and then the interval. So what I need to determine is how these values are actually packed into the message and sent to the device. Unfortunately for us, we don't have too much to go on in terms of how to actually stick these in there. If we go into ILSpy and check out our read sector memory, where is it? I'm blind. There it is. And we analyze this. Go to used by, display pad worker, used by, do. All right, so we determined that the default values being passed to this, wherever those are, I'll find it here in a second. Use device plug. Let's just keep going into this. Used by. Is it this one? No. There it is. Ooh. So this right here, this is our default values that the native software sends to the device. We've got our sector index is 0, I address is 0, number 4096, and then just to confirm, yeah, it doesn't actually change anything when it calls that that function from the DLL file. So in our Python, let me go back to Linux and we can take a look at the Python that we were working on. So this is what I had being spit out. Let me oops. All right, and we'll see what this spits out. So this should go through and spits out this. So our packing is a little bit off. Okay. Let's just trim all this crap off the end. That way we can look at these kind of the same. So our packing is a little off. It looks like we're packing too many values in here side by side, or we're not shifting the values properly or packing them into a singular value, because I think that's probably what it's doing over in the native software. I think. because it's doing some shift by 8, but that may also be wrong. It may also just be ghidra getting that wrong from the decompiling. Because if I look at the no, that's a shift right. What is this? Is shifting right to EBX. Um, what is an EBX? Okay. I'm not too sure. Doo -doo. I'm a dummy when it comes to the actual low level stuff. I'm still learning all that. So, um, I'll just bash my head against it until I figure it out, right? So let's take a look at the actual code. Where is that? It's over here. So I don't think we need to, um, sector edges, 0, eye length, and then interval. So maybe we don't actually need, this as a whole ass integer. Maybe that's just a byte. What is that supposed to be? That's supposed to be, um, man, I did it again. I do that crap all the time. Sorry. If I'm on the wrong screen and I'm talking about something and it's not making any sense, just say something. um, this sector index is 0, IP address is 0, number 4096, and then they pass sector index, address, number, and then in ghidra, sector index, sector index, IP address. Okay. Let me rename this sector index, and then the uint is an I-length. What is sector index? These are all integers, at least as far as that's concerned. I-length, and then wait a minute. I sector index, I address, I length, and then it calls sector index, I length, p data. Sector index, I length, p data. Okay. And then our interval and then ID. Okay. Sector index, I length, p data, interval, and ID. Sector index is 0, I address is 0. Rewind it about. Okay. Um, integer 32. A 32-bit integer. So maybe if we go into ghidra and we change this, oop, what did I just do? I just highlighted it, that's fine. I retype the variable to int 32. So just uint. There we go. And then I_interval is also a uint. What? Oh, Control L. Uint. There we go. So these are supposed to be 4 in length. So 4 bytes in length. The Python struct is that. Standard size is 4. Oh, maybe it's because I'm passing that extra value because we don't really need the get the sector index, the length, right? Let's see. I'm just copying some stuff out so that I can actually work on it without having to go back and forth so many times. Okay, so we've got, this is what came out of IL_spy, and this is ghidra. Okay, so what we're working with in our code is we are passing, we've got our header, which is good. That may not, maybe that's the issue, is the header is, no? One, two, three, four. And then we've got, let's see, 2, 3, 4. That's our second one. And then this is our fourth one. I think that's right. Yeah, so we actually need to divide this up a little bit more. What is it doing here, though? Why is that packed like that? No idea. So in our wireshark, let's go ahead and open our capture. Let's see, my computer, test disk. Actually, I've got that, where is that? I done lost it. There we go. Let's do our startup pcap. Check that one out. Let's get our, let's get our column added, our HID data, apply as column. All right, cool. Ew. Why is it like that? That's annoying. Okay, so we are looking for 1.9, right? This one right here starts with 1.9. Got a bunch of other crap, and then our 1002. Let's see. So it takes our sector index. Let's start from the top. So we have our sector index that's added to the stack. That is interval. What is that? That's stuck into a, what was that, a 16-bit pointer? I don't remember what that was. That's right. Pulls the 8 low bits from that value. At least I believe so. Oh. So is it taking, because this is a 4-byte value, this integer is a 4-byte value, and then it's sticking it into the AL accumulator register, which pulls off the lowest 8 bits, then is that effectively truncating it? I think that's effectively truncating it. Let's see, x86, int into AL. I don't know, I'm not even sure how I would look that up. And then the DL is also, I think that's also the same data? Yeah, that's also 8 low bits. So they're taking EBP, which is a 64-bit stack pointer, and I guess they're taking their 4-byte integer value out, sticking that into the AL register, and I'm assuming that that chops off like the chops off all the extra data that's not really necessary, so that they can more effectively pack it. Because this is undefined 1 byte, and this is, the length is 4. Yeah, really not too sure what I'm looking at. I think we need to bit shift the same for our 0 value and our interval. Let's check. I don't even think that's going to do anything. Except maybe throw an error. Yeah. Oh, expected 3 items, got 4. We do need to send 4 items to it, though. Because we're passing sector index, address number, integer pointer, and then it's the pointer for the data that you're passing, or that you want to spit it out to. And then the actual, shit, I'm doing it again, every time. So the actual in ghidra, the message that gets sent out, let's copy that. And I want to stick it over here to look at. Okay, so got our sector index and our eye length. We have our length and then index. No, wait. sector index bytes. But right here, shift those by 8. The length. We're already shifting by 8, and then interval is 2. Let's see what that comes out as. Probably an error. Wow! That's not right, though. Because if we paste this right here, we're still off a little bit. That's weird. Alright, let's try one by one. Let's go one by one. I think it's still gonna pack all of those bytes in there. Even if I shift it, I need to do the character bytes of length 1. I think that's what I need. So this will be character, and we're gonna put our, what do we need in there? Sector index, length, and then interval. And it'll probably throw an error, because that last one is an integer, not a character. Yeah, bytes object of length 1. Okay. What if we shift that to the right by 8? Is that gonna get it into the length of 1? No, of course not. Oh, is it whining about that first one? It could be whining about the first one. Let's see. I said we'll do one at a time, and then I'm sitting here doing them all at once. Yeah, character format requires a bytes object of length 1. Oops. I need to remap that. Hey, what's up, Conrado Fix? How are you? Let's comment that out because I don't want that throwing errors. I just want to look at these values. I mean, that looks like a byte value of length 1. Okay, so let's see if it appreciates that. Let's not do the shift. I don't need to do the shift. Because that may just be my issue the whole time, is that I just need to be working with raw bytes data instead of trying to do, like, some other crap. Alright, and then let's do the length. Right, sector index, and then length. And then let's do length, shift that by 8, and then we'll send all of this to bytes. Dot 2 bytes. And we'll add another character right here. Let's see if this whines and complains. Nope, that seemed to be okay. So let's go to our next value, which is the interval, right? So the interval is going to be 2 equals, do we need to shift that? I don't think we need to shift that, but we might as well. Does shifting it even do anything? I'm curious now. Let's just do that. I want to see what it does if we don't shift it. Oop, we'll leave it the same. Let's see if the values come out. Yeah, KDE is pretty nice. Yeah, integer too big to convert. I guess that's why they're shifting it over to drop off all the extra data at the end of the integer. Because if you only need like 1 byte and you're storing it in a 4-byte integer value, you want to be concise because you're sending it to a USB device. Obviously, you would lop off the extra unnecessary bytes and only pack it into 1 singular byte. So let's shift that by 8 to drop those off. And I don't think we're using address bytes. I don't think we need that because it's sector index. We have our length, integer, C and C, and then let's do interval. I've been using Wayland as my window manager instead of X11. It's all right. And then we'll do 2 bytes. This looks really ugly and gross, but hopefully I can come through and clean it up later. Did I get the interval on there? Yeah, okay. Pack expected 3 items, got 4. Oh, I forgot to put the additional character item that we're packing. Okay, and did that not pack it onto the end or what? Huh, interesting. Let's try not shifting it because maybe it is actually dropping it off. There it is. So I guess shifting that to the right drops it off because it's already a small value. I'm not sure how that works specifically, but whatever. Let's go into ghidra, just double check. So we've got our sector index, our length, and our interval. And then that gets stuffed into local 50. I'm guessing these are getting stuck in there too, but I'm not seeing that actually make it into this. Stack pointer into ECX. EBX, ECX up here. This does an XOR. Sector index, interval, and length. Yeah, I'm not too sure. Let's just YOLO go with it, and we'll send it. See what happens. Because I think we're packing it properly now. So if I like take this value and compare it against what we've got up here. Oh, no, we're a little off. A little off. We're getting closer. I think we're missing another byte, another 0 byte right there. So we've got our header, sector index bytes, our length, and our interval. Sector index bytes should be 0, right? So that's printing that out. Maybe that just needs to be a full-ass integer. Because I don't think they're doing that to the index. I don't know. Let's go ahead and set that as an integer. Let's rerun that. See if everything comes out right. Oh, oops. All right, that might be right. Let's compare the top value with the bottom value. Nope, that is not right. Okay. Oh, interesting. Oh, nice. Debian 12 with KDE. Cool. Debian's pretty solid. Honestly, they're all Linux distributions are pretty solid. It just depends on how much effort you want to spend getting it to do the things that you want it to do. So it says our sector index, we've got that set to a unit up here. And then it goes, and this local 50 is memset local 50. Is that 64? Is that supposed to be setting my destination? Let's see what that is. So first parameter is a void, pointer to destination. Second value is integer value, and then size. So it sets a memory region. What is IVAR3? Oh, the device table. So that's if the device table handle doesn't exist, or yes. Or I guess message handle, I don't know. I'm not sure what it's pulling from the device table. Not too sure how to look at the virtual memory addresses yet. And then, yeah, so I think that's setting that message size as 64 bytes. So if we go into memory, if we go into Wireshark and we look at this, this should be, yeah, 64 bytes of data. So I think what this is doing is this is setting the data. It's basically pre-configuring or presetting the memory allocation for 64 bytes of data, and then it comes into here and it starts sticking stuff in there. I'm not sure what this syntax is. See if we can figure that out. 0 is the index, 1 is the size. According to this person. Ah, interesting. You can turn that off. So it says that helps them. Okay, I don't think that's entirely helpful, but so this would be the first one. So based on that, let's go back into Linux and we'll reorganize these based off of the order that they're stuck into the. Yeah, I kind of started to do that a little bit. All right, so we have that. We have the sector index. So length of 1 byte. This 0 is a length of 2 bytes, I'm guessing. So what we need to do, and then what in Python struct is 2 bytes standard size. We have a short, we have an unsigned short. Um, let's just do a short since that's already 2 bytes. We'll do H, and let's see. So we've got our sector index, big fat 0. I'm not sure what the hell that's for. And then we have our length and then interval. So we want that one, the index bytes, sector index, or no, we want the 0. C, and then we put a 0 here. I wonder if that'll work or if it's going to whine at us. Let's see. We'll take that off before we get too far ahead of ourselves. Start stacking up a bunch of errors. Yeah, character format requires bytes object of length 1. You're referring to, yeah, the sector index bytes. Dot 2 bytes. Okay. And then got our 0. And then let's do our length. That's going to be another character, right? Maybe not. Let's double check in ghidra. So our length, this says that it's a integer, 4 byte integer, but undefined. Um, oops. That's interesting. I guess that's because it's assigning it into a 1 byte value. So where is it actually doing that? So it takes our length value, puts it on EAX, shifts it to the right. Or no, wait, that's EBX. Oh, right here it does the shift to the right. Oh, okay. Let's see. And length. So we are shifting that one. Sector index bytes. And then interval. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, let's let it whine. No? No whining that time? Alright, let's see if this lines up with our data from wireshark. Ooh, look at that. Interesting. Interesting. So maybe we can actually send that to the device now. Let's do it. Let's send it to the device. Alright, so we want to... I'm going to do this interrupt out. Get all this stuff. And we'll print that out. No, wait, we want to print the response, right? Just double check how we're doing this over here. So r equals self interrupt out, we send the message, and then if r, and then we print r. Okay, so let's do r equals self interrupt out, and then if r, then we print r. Right? Okay. So I should actually send it to the device now. So if all things go well, we should get a UUID back from the device, right? Come on. Ooh, look at that. We got ourselves a UUID. So this is what it responded back with. And if we compare this to our wireshark, so this is what we got from the device. Let's go back into wireshark over in Windows. This is the message that we got. Let's do copy value. Go back into Linux and paste the value. Here we go. Nice. That's sick. Now the question is though, is the device waiting to send us more data? Because we asked it for, what, 4096 bytes of data? So if we got 64 and we asked for 4096, is the device waiting to give us more? What is that? That's also a UID? Well, this message starts with 1A? That's interesting. I don't remember seeing that. Huh. Alright. Okie dokie. That's interesting. Maybe we'll have to figure out what 1A is. Let's see, see what that command is. It gives us the same thing. So maybe it's using a different function in the binary or in the DLL. Like what other function would it be using? Be like get FW info? Might be that, get FW info, right? What does this do? This does let's rename this. This is param2. We can go into ILSpy. Let's see if they got this one exported or added into here. I'm not seeing it. Let's see. Yep, there it is, get FW info. So I call that with the reference to FW info, which is a struct. Unit ID. Okay. Let's analyze that. Used by this one. All right, so this does get the FW info. Nice. Is it pulling it out and then converting it into JSON? Because that's kind of cool, if that's the case. So get fwinfo, we send it a reference fwinfo, convert, and then the ID. Okay. So this is going to be a reference fwinfo and then convert. And then this one will become ID. And I don't know if we can actually retype this to like reference or something. I guess it's just gonna be a pointer, right? Leave undefined for now, because it's just passing the ID into this. So let's come into here, see if we can find the message header. Message header for this one is 11, so I don't think that's what we're looking for. What about get device info? I don't think that one's actually sending it to the thing. Get device app version. QT sleep time. Firmware layout, maybe? Nope, that's also 11. Okay. Hmm. I don't know. Let's check to see if our device is still waiting for us to grab more data. Damn, I was in Windows that whole time and you guys didn't see any of that. Wow. Okay. My bad. So we have the message set right. Let's go ahead and add some extra logic into our code to keep pulling from the device. Because it responds back with this, which I believe this tells us that we have more data to pull. And then I think it's got like a null byte or just like zeros, and then this is the data, I think. Because if we look at the wireshark data, we've got this. This is our host asking for data, and this is the device sending it back. And then you can see this hex value, this 43 or whatever, this one keeps counting down. So I think that's kind of like our index, right? That tells us how many more packets or how many more messages we have to pull back from the host. And we keep going until that gets to 0 right here. And then we'll see a bunch of F's at the end. So I think that's kind of the logic that we need to follow in our code to pull back more data from this device. So yeah, that doesn't seem too bad. We just gotta get the message back and then dissect it, kind of do an if check. If this value is greater than 0, then we keep going. I'm curious though if all this data, oh, see, this is probably like 2 bytes. Or sorry, one integer, so 4 bytes? No, that's 2 bytes. That's 2 bytes of data. Hey, Drake77, welcome. I'm reverse engineering a little piece of hardware. It's called a little display pad by Mountain GG. Mountain GG is the company who makes it. It's meant to work on Windows. It doesn't have Linux support, so I'm coding my own drivers. At the moment, I'm digging into the read sector memory. There's a function that the device has where you can read data from it. It's got like some memory sectors or something like that embedded into the microcontroller or into the flash, wherever on the hardware. And there's a function that you can call over USB and it'll spit data back out. So I'm implementing that in my own Python code to actually get some results from it. So far, I implemented it to the point to where it passes back the UUID, which is like a universally unique identifier. So in Wireshark and on my Windows VM, this is data that was like captured from the host talking to the device over USB. And this message, if you look right here, we've got our sources, our host, our destination is the USB device. So our host was sending out a message saying, hey, I'm asking for data. And then the USB device is replying back with all of that data. So I'm working on implementing the actual steps to continue querying the device for the remaining data. Because I think right now it'll just be sitting there waiting for you to ask for more data until the end of time. So I need to implement that, otherwise it'll get stuck in like a hung up state. So what I should probably do is check to see if this value is greater than 0, and if it is, then we need to start doing some stuff. So this value that I'm getting back from the interrupt out, response return, interrupt in gives me Banasky, hexlify. So I don't know, I might want to like convert that back into a byte array so that I can check it. I've been back and forth on this a couple times with this library that I've been writing on whether or not the interrupt in messages should reply back as just straight byte arrays, or if they should be like human readable hex arrays. I guess for now I'm leaving them human readable because it helps me debug it. I could just have it log it, but it's probably better to have it operate on byte arrays. But so real quick, I'm gonna take a break. I've been going for about an hour now. I have to go to the bathroom, so let me take a break really quick. I'll put you guys in my little idle screen where you get some cool jams. So give me just a couple minutes, and I'll be right back. Yo, what up? Okay, I'm back. So let's get back into this. Um, so it's gonna be spitting our message back out. Let's go into make sure you guys are looking at the right thing, because I always do that. Okay. Should be looking at Linux. Um, so this should be spitting out our message. I need to check and see if let's actually go through. I want to change this. I'll deal with the errors as they happen. Because this is kind of like what I'm doing right now, which really sucks. I mean, it's not the worst, but I don't. Well, eh, let's stick with it. It'll save more work or save effort. I won't have to like go through and do that crap. All right. So GG read sector memory. Print R if R. And then let's see, print R. Let's see if how do we do that? So we gotta take the byte value and then we gotta convert it into a number. And then check and see if it's 0. And if it's not 0, then we continue and request it again. Um, let's just slice this real quick. Print R. What do we need? We need 1, 2, 3, 4. I think we need 3 to 4. Let's do 2 to 3. That should give us the 4th element. And we'll see what that does. And it may throw us an error because the device is still waiting for stuff. Give us an 8. I need to print the whole thing so I can see what we're dealing with. So I think the problem we'll be running into is that I'm converting this byte array into an ASCII array, and then it's going to be, oh yeah, see, it's not ready. It's still waiting on stuff. 118, that's our header for enable, right? I think. Where is AP enable? Oh, that's 8001 or 1108. No, wait, that is 1180. Yeah, okay. Attempting to write 9. Okay, and then that's the full message. So I need to check and see if I need to check to see if we've got 19 in the first byte. Because if we have 19 in the first byte, then that tells us that that we got our message back appropriately. If we don't get 19, in this case, it's sending us 1180 as our header, and that tells us that it's still waiting to send us data. So I need to check to see if we've got 1180 in the header, and if it's got 1180, then we need to pull more data from the device. So and maybe I need to do that in the it might be better to do that in the interrupt out, or sorry, interrupt in function up here. Length is 64. Because it is only sending 64 bytes at a time, so I need to I need to keep calling interrupt in until I've got all of my bytes back, and then I'm done. And then it's ready for another request or another command. Otherwise, it gets stuck in this like kind of limbo state where it's waiting to send me data, but I haven't requested it yet. And I don't want it to be stuck in that state, so we need to add some checks in here. So I think what we can do is, let's do, we do want the byte array. Let's do this. Response equals byte array. If response, for, let's see, we want to be 1180 in response 4. Then what we're going to do is we're going to call interrupt in again. Actually, that may be a bad idea, because then we're getting into recursion, and recursion breaks my brain. Because if we're doing that, we'll want to pass the value back to itself to keep kind of piling up the messages. And instead, what I think we need to do is outside of this function, we shouldn't be doing this here, because if we do it here, then it's not going to be, what's the word? It won't be compatible with other functions, is what I'm thinking, because this device is very particular. Some of these headers, like if we go up to the headers up here, some of these headers are not consistent. Like set panel image is like a full integer, and then we've got like the AP enable has like a start and a value, or has like the header and then a value. So it's not super consistent, and if I'm expecting a particular consistency amongst all of these functions, then I might run into headaches. So I think I might stick with what I wanted to do, which is not have it spit it out as bin ASCII, and instead spit it out as the byte array. That way we can handle it easier. And then what we can do is we can also make a function for parse message or something like that. So def parse response. We do like message, and then return bin ASCII.hexlify message. That way, if we want to, or if we need to get it into that, we can just call parse response really quick, and then we can also do some other stuff to handle things in here later. So interrupt in. Let's spit that back out, and that should come down here to interrupt out, and then let's print it. Print R. And we'll run that. It's probably going to give me the same thing, but, or it's going to error out somewhere else as it goes and tries to do other stuff. Yeah, device is not AP enabled. Failed to enable. Okay, so let's go deal with that real quick. So we need to get these first two. Let's try that. I think that ought to work for us. Device is not AP enabled. Okay. Print R slice 2. Let's just print R. See what I'm working with. Yeah, I think I need to separate these. Slash x11. See, because this isn't a byte array, this is like a byte string. Um, okay, so that worked. So we'll have to do that to the rest of those as they give us trouble. So, which is not the worst. I wonder if we need to actually, you know what? Let's see if we can do that based off of the message header. Like if we can do 0x11, 0x80. And then down here under AP enable, we can do 0x11. Those are 2 byte values? Or 1 byte values. And then we'll do C and C. No, wait. CCI. There we go. Hack that in there. See what that does. Probably throws an error. Yeah. Okay, so character format requires bytes object of length 1. Um, can I do a short? I don't think that's right. I don't think that's going to show up right in the message as it gets sent to the device. Device is not enabled, byte array, blah 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 blah. Yeah, I didn't like that. Okay. Let's print this really quick. Oh, here. You know, it could just be looking at the log. I have this all logging out. Oh, it's huge, dude. Alright, let's delete all this. Oh, what? Bruh. Alright, our log file. Oh, I guess it didn't write into it this time. Okay, whatever. Get our logging set to logging set to debug. Okay. I don't know. Whatever. Um, so let's see what that is. It prints that. Yeah, I guess it's not getting to the do I have to prep the message? Not doing that for this stuff. But that's also a way uglier function. Okay. So it sends this, that's what it's sending. It's got that extra 0 at the end. I need it to be a singular value. Can we do... No, because I want to pull this. Our command is AP enable. So let's get our URB headers and command. Header equals URB headers dot get command. Because I kind of want to have this like simplified, but I'm probably just making it more complicated for myself. URB headers get command enable. And then we can pack this as let's do byte array. Right, that'll do that. Okay. So that gives us a byte array. And then we can do something like if header. This is what I want to do, if header in, and that way we can check to see if we got the header back from the device. Let's do that, print it out. Oh yeah, card argument is not an integer. Bytes, bytes, bytes. I need this. Let's check the notes. For this format character, the count is interpreted as the length of bytes, not a repeat count like for other format characters, for example, 10s. So I should be able to just have s and then character elements mapping to or from 10 different Python objects. Defaults to 1 for packing. The string is truncated or padded with null bytes as appropriate to make it fill. For unpacking, the resulting bytes object always has exactly the specified number of bytes, as special case 0s means a single empty string, while 0c means 0 characters. Interpreted as the length of bytes. Okay, so what we can do here is, and this is going to be length of, is it header? Length of header s. Let's see what that does. Oh, we need the I back here for the enabled. Ah. $1180.01. I think that's what we're supposed to be getting. Let's double check. Back over here. 1180. Um, that's right, that's because that's a full ass integer. I wonder if it actually cares about that. Or if maybe it's just looking for the 1180 and then the next value being a 1 or something. I don't know. I don't know how picky this thing is. Okay, so that worked. And then this whines. Where do I learn about reverse engineering? It's a good question. All over the place, honestly. It's really just the practice of like diving into a particular subject and picking it apart and learning more about it and peeling back the layers and layers until you learn more. So like I never started knowing all of this stuff to get into this. You just kind of start with one thing, like whether it be learning Python or learning how networking works, or learning how USB works. So when I first started this project, for example, um, I don't know how devices talk to each other over USB. So I just did some research on that to figure out, how can I actually sniff USB traffic? And it turns out that you can use wireshark to do it. So I started sniffing USB traffic and trying to figure out, try to make heads or tails of it. And you kind of do that for whatever thing you're interested in. Lots of reading. All right, so our API enable command is getting sent back, and that is getting interpreted as true. And then it attempts to send that. Wait a minute. Oh, maybe I do need to prep it, because we need to pack it into 64 bytes. I think that might be why it's whining. Can I create a Discord channel? You're the first person to actually ask that. I've been kind of holding off on it, mostly because I don't have too many viewers at the moment, but I might look into it and throw it up there for you guys to hang out in. And we can all chat and learn some stuff together. So I'm not prepping this one. Yeah, we're gonna have to come back there and redo all of these functions. But that's okay because it'll be better. Because then I'm not actually just digging through ASCII data and I'm looking at the actual raw byte values. So let's go ahead and I'm gonna clear that out just so it stops making a bunch of noise in my print. Do I still have my log open? No. I still got nothing in it. Okay. Okay, attempting to write 64 bytes, and then that's writing the 9 bytes to endpoint 4. That is our, where is it? GG read sector memory. Okay. So now let's go ahead and what we need to do is we need to check and see if we've got 1180 in here, and if we've got 1180, we need to pull more data back from the host. So interrupt out. Make sure, double check that this is actually okay. That's the length, gets the buffer size. Okay. All right, I'm not going to worry about that for now. Just gonna get myself into another rabbit hole. So let's check to see if, so I'm gonna check to see if we get a response, right? And then if, byte array, or actually, if not, header, oh, header not in, and what is this going to be? This is going to be slice that, Ruby headers get command, and what do we want to do? We want to join this, right? Dot join. Or no, we just want it into a byte array. That's right. Byte array. And then down here where we're packing the header in, this is going to be the length of header, and S for string. Ah. Print R. If header not in, then what we want to do is let's see, while header is not in, we want to call back our we might have to build like a, because it's kind of like pagination, if any of y'all are familiar with that. We need to like, we're working with a small buffer of 64 bytes when we get it from the device. Here, let me go into Windows and I can show you guys what I'm trying to emulate. So this is the command that gets sent from the host, this 19, along with the 01, blah, 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 blah. So this gets sent from the host, and then the device itself responds back with 64 bytes of data. And because our initial command requested more than 64 bytes of data, we need to keep polling the device and asking for more data, more and more data, until this value right here gets all the way down to 0. So you can see it's down to 11. I'm sorry, here now it's down to, there we go. So it gets down to 0. And then that's how we know we're out of data. So we've requested all the data from the device has given us all the data, and now we're done pulling data from the device. So that's, I'm trying to emulate that actual like logic flow. I hope that adds some context. So I'm just trying to rewrite this function, this read sector memory function that I have. I'm trying to rewrite it so that it can either keep calling itself or just keep calling the interrupt in function. So while header's not in there, then what we'll do is we'll just do data equals byte array. And then what we can do is, while header is not in, we'll pull that back. We'll pull back more data. So we're going to do data. Trying to think about this before I go and start typing a bunch of stuff, because normally I'll type a bunch of stuff and then go rewrite it if I don't. So if our header is not in the response data, and this might shoot us in the foot later, because we may need to check to see if this AP enable header. This one right here is in the data, because if this is in the data, then we need to keep calling it. But if it's something else, we may not need to. Here, let's just write this out in comments real quick. So, if device is waiting to send data, call int interrupt. Interrupt's got two R's, right? Call interrupt in until header is in message. Okay. And then if our header is in the message, add the response data to our total data array. Check the remaining data byte to see if it's 0. If it's not, then we'll ask for more data. So that's kind of the gist of the logic, all right? So if our device is waiting to send data, call interrupt in until the header is in the message. And that tells us that we've got our data back. R equals self dot interrupt in, and we want to, what do we call this with? Default should be fine. Yeah, I think default should be fine. And then let's see, I think we can do that. So if the header is in R, oops, length of header, then we break out of this. Right? I think that's what we got to do. And then that will let us do data dot append. Or we want to slice this past the 4th byte. What do we got? What do we got? So this byte value. And that may be, there's also this one. I'm not sure if that is part of it as well, because the device itself only responds back with so much data. I haven't seen any examples in the actual USB traffic where there's more, if there's more data past that first packet that it sends back. So like this first packet that it sends back this, and there seems to be like a little gap right there. So I don't know if that's just like null space to kind of separate the actual data from the device and the packet data. Because it might do that to like distinguish, you know, hey, this is the actual information from the device. This is all packet information with our header and then our index. But then you would also need to know like how long is your index. Is that basically what I'm getting at is the index only like 1 byte long, or is it sometimes 2 bytes long? And so I need to account for that. I'm going to assume that it is 2 bytes because that's what it looks like. And then everything after that should be our actual data from the device. That might be a good assumption to start with. And then if that doesn't work, then we can adjust it later, I guess. So data pinned, we want to grab everything past the second. So we want the third and on. No, wait, fourth. Fourth, right? So it's going to be the third and the fourth. 3 through 4. What do I need? I probably got that wrong, but whatever. And then let's see, let's print this out. Let's print out the index, and we will print out the data just to see what that looks like so that we can make sure that we're on the right track before I get too much broken code written. The argument S must be a bytes object. GG read sector memory. Why don't I use AI for speeding up my writing and coding? Because it's boring. I like to do the code myself. It's more fun. It requires thinking, and that's kind of why I do the whole thing, is so that I can think and I can learn. I could use it, but honestly, it turns into more of like a babysitting session where I'm babysitting an AI instead of actually doing coding, and that's just not fun to me. I might mess around with it later because there are some projects that I want to do. Like I've got this got a laptop with some the AMD, was it Ryzen HX AI cores. So I kind of want to try and play with those a little bit and see if I can get those to do stuff for me. So I might mess around with it a bit in the future, but honestly, it just, I don't know. It's more fun to type the code myself. Besides, it gives me more time to think, because if I do more thinking than I do typing, then usually the result is better. So this spit out, we've got to change that bytes object. Where do we go? Down here. I'm getting lost. So this needs to be our header. Ah, there we go. That's probably why. Just make sure our header is right. Read sector memory 19. Yeah, I think that's right. Okay. Run that again. Battery object cannot be interpreted as an integer. What the fuck does that mean? Oh. Because I don't really have anything in there, I don't think. There's nothing in the, let's do R. Set that. No, we actually have something to index. I think that was the, that's why it was whining. No, it's not. It was unfortunately whining for some other reason. Actually, let me reset this device and remove it. Oh, hopefully this doesn't blow up my host. Ah, it's blowing up my host. Sweet. This like totally locked up the VM. Wow, that's crazy cool. All right, hold on. Okay, guess not. Let's see. Oh yeah, man. That VM is boned. Got cooked. Hold on, I gotta restart it. Do, 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 do. Good thing is my system hasn't crashed yet, so that's cool. My VM did. Wow, it's really locked up. Holy crap. Wow, okay. What the hell? Uh, that's very interesting. I don't know why that VM is locked up. My Windows VM still works, but the Linux one, that one is cooked. Yep, I mean that is working. Okay. Anyway, let's take a break for a minute. I'll work on getting my VM restarted and I will be back to it. So put you guys in the idle room with some cool jams. I will be back in a couple of minutes.